Welcome to another Mammoth Site video where we're going to be discussing some scientific concepts. It's going to be going on our YouTube channel, maybe a snippet or two on our Facebook, and undetermined yet. But we're going to be talking a little bit about something called biogeography. And to help me talk about biogeography, I brought one of our interns. So we have a lot of interns that are helping us through the summers. And in the summertime, they bring about all their expertise and all the stuff that they study here. And so Colin here is going to be talking with me about biogeography.
Hey Seth, have you heard about the Gabi before?
You mean the Great American Biotic Interchange?
I do, yeah.
Absolutely.
Awesome.
Before we get into that, though, let's kind of start with the word biogeography. So it's kind of a combination of a couple of words. So first and foremost, you got bio, which I'm assuming is biology, the study of life, and then geography. So geography being, okay, where stuff's at, maps, things like that, where stuff is located. So is biology or biogeography just where life is located?
So it deals with the geographic distribution of species and how they get where they are today, as well as maybe where they got in the past for extinct species. So if a species starts in South America, but then we see it in North America and Europe, how did it get to those other two continents? That's what biogeography is a little bit.
Yeah. And so when we look at biogeography, how does it relate to the Mammoth Site itself?
So what's interesting is that if we have our 6 main species that we see in our diorama and around the area at the Mammoth Site, 4 of them are endemic species, but 2 of them, the 2 that we really have in the sinkhole, are actually species that came from somewhere else. So we can follow their story to figure out how they got here.
And so when we look at biogeography, when we talk about things moving to different places, what causes that?
So that deals a little bit with land bridges as well as seaways if we're talking about sea creatures. But it's all about, hey, new real estate opens up, guess it's free real estate, gonna go move there.
And so with that, I'm assuming it also kind of has to deal with things just like much like with the land usage, whatever resources available. So if there's more land in an area, that as a land bridge is exposed, that means there's going to be more plant life, which means your herbivores are going to go there, and then once your herbivores go, you're going to have your carnivores, and then you're going to have see a little bit of play between those.
It's a wheel. Don't break the wheel.
Alrighty. So when we talk about the mediums for this, so we talked about land bridges. So what exactly is a land bridge? The best way to describe a land bridge is it's basically when you have sea levels lower, you have a strip of land that connects 2 places that were previously blocked by some body of water. Arguably the most famous one for North America is probably going to be the Bering Land Bridge, or Beringia, which connected Eurasia to North America via Alaska and Siberia. So where the Bering Sea is now, there used to be at one point in time, after when there's massive glaciation, you would have a bunch of that getting locked up. A lot of the ice water getting locked, the seawater getting locked up. You would see that, kind of that land being exposed and then animals cross through that. What are some other examples of ways that we can see biogeography?
Well, we can also see biogeography. For instance, another famous land bridge is the Isthmus of Panama. And the Isthmus of Panama, after it was created, allowed fauna from North America to go down to South America. And sure enough, we do see saber-toothed cats, which were first here in North America, down in South America, and we see some species of terror birds come up here to North America, and we're like, wait, the only place they were is in South America. How'd they get here? Or sloths somehow swam here. Where did they come from?
And that's an important thing to mention too, especially when we talk about the connection between North and South America, is that it isn't all the time. It's not just one event where all of these animals go from okay, we're here, now we're here. It usually happens kind of slowly through time. For the most part, things aren't instantly going to be like, oh, I'm going to go right over here. So you have to keep in mind that it is going to be a pretty gradual process. So they move slowly through time. They're just kind of expanding. They're like, oh, let's wander here a little bit. Oh, let's wander here a little bit, and just kind of so on and so forth. So we've talked about the one through the Isthmus of Panama. We've talked about the Bering Land Bridge. Yeah. What's another example of a way we can do we can see biogeography and what influences it?
Well, there's also seaways. So for every land bridge that created, a seaway is closed for animals that are living in the ocean. Those animals count too. And so, for instance, much of the middle of North America, such as Kansas, used to be part of an ocean. Heck, even South Dakota used to be part of an ocean.
Yeah. We can see evidence of this ocean that we call the Western Interior Seaway. We can see it through the fact that we have fossils like ammonites and mosasaurs throughout it. So it's a pretty good indicator when you see fossils from an oceanic environment and you see them through time and you see the rocks that accompany that there had to have been a seaway there at one point. And so when we look at those, so we talk about the western interior seawall, especially in South Dakota, just because it was covering a good chunk of South Dakota. If you're ever visiting South Dakota, you might see some of those darker gray shales in some areas. Those are often part of the pure shale group, which are pretty good examples of that. You also have like the Niobrara chalk, which I believe is more exposed in Nebraska, but there's still evidence for it. But yeah, it basically stretched from all the way from Canada down to the Gulf of Mexico. All right, and when we talk about these migration events, these times where we have one group of animals move to another area, it's important to understand that it's not necessarily like they have a destination in mind, right? Like, for example, we've been talking about the Gaby, the Great American Biotic Interchange. That wasn't one singular event, right?
No, it was actually 4 waves. So the earliest wave started in the Miocene around 10 million years ago, and then the last wave was potentially the largest, and that one happened in the late Pliocene around 3 million years ago, when the Isthmus of Panama finally formed and North America collided with South America.
And so when those earlier waves, because we're talking about how there was a land bridge like that Isthmus of Panama, I believe it was the sloths, right? That were we have evidence that they're pretty good swimmers, so they might have swum basically from island to island up and made their way on up.
Yeah, exactly.
Awesome. Yeah. So again, it's kind of important to remember that when these animals are moving, they're not necessarily planning on going, I have this destination in mind. It's more of, I'm kind of following the resources as we go, and then, hey, here's a new area. And then, of course, as with all animals, they adapt to their environment through time. It's not like one individual animal is like, I'm going to do this to be better for my environment. But through time, through successive generations, the environment selects for certain ones that are better suited for that environment.
Yeah.
And it's really neat too. So we kind of talked a little bit about how, so we can see it during the Mesozoic, during the time of dinosaurs. Some of that's going to be influenced by the fact that with plate tectonics, you're going to have continents moving. So you might have 2 parts that are put together that are no longer like that, and they're split apart. But then you still have animals living on those. So through time, as they get separated, they adapt to different environments. But we can also see it in modern times as well, right?
Yeah. So closer to modern day. So proboscideans, like we have here, mammoths, right? Where did they start? Well, they started in Africa. Well, the thing is, if they started in Africa, how did they get here? Well, 19 million years ago in the Miocene, Africa finally said, it's time to get close to Eurasia. And they crashed together. And when they crashed together, all them proboscideans said, it's free real estate. And they crossed over to Eurasia going, hey! And then, of course, from Eurasia, there's that other land bridge, the Bering land bridge that opened up, and so then they came to North America, and you know what they said? Hey!
Absolutely, and then of course, with those animals, we can see some of the smaller ones. So we talk actually. Speaking of that, we've talked about how the proboscideans they basically came from Africa and then crossed into North America. And so it kind of seems like a one-way trip, but we also have some animals that are found only in North America, or that just got their start in North America, that we see in other places now, such as, well, for one, the entire camel family, so camels and llamas. Camels went to South America, llamas went to South America, and camels went over to Eurasia.
Yeah. Yeah, we also have horses. Horses started here in North America, and at the end of the Ice Age, some of them went over to Asia, and luckily those ones survived, where the ones here in North America did not. And then, a little-known species, Homo sapiens, domesticated them later on, and then Europeans brought horses back 500 years ago, so it was kind of like a coming home party.
Absolutely. So we've been talking a little bit about this in the abstract, but what I want to focus on is in particular how this relates to us at the Mammoth Site and what it does for the rest of understanding of biology. So how is biogeography helpful for understanding the Mammoth Site, and what does it do for us when we study biology in the evolutionary sense?
Yeah, so the Mammoth Site, we got 2 species, mammoths and the short-faced bear. Both of these animals are actually migrants, like we've talked about, from other places. So the short-faced bear, we think their ancestors came across that Bering land bridge somewhere around 5 million years ago, so during the Pliocene. And then once they came into North America, they evolved and spread around, and then we see short-faced bears here in South Dakota at the Mammoth Site, so hey. As well as mammoths, they also came across that land bridge, and then they spread around, and we see them all over, including here at the Mammoth Site. And that same land bridge, some animals came in, and some, like we talked about, the camels and canids, such as wolves and coyotes, went out.
And so that's one of the really cool things about being here at the Mammoth Site, since, as the name implies, we have a lot of mammoths, but we also actively look at dating and figuring out exactly how old our site is. So part of biogeography, if I'm not mistaken, is figuring out when things are where they are.
Yeah.
So okay, they were in this area at this time. Is that before or after they were in this area at this time? Because assuming if we're looking at the fossil record, we can't exactly be like, well, these guys were over here. Oh, but they're also over here. They were there at the exact same times. There might have been some time in between that.
Yeah. Yeah.
Alrighty, so we've been talking up a little bit about that. With biology, though, with talking about biogeography, it kind of helps with understanding speciation, if I'm not mistaken.
It does. It also helps with phylogeny. So phylogeny, right, is our tree of life, figuring out who's related to who in terms of evolutionary relationships. So if we can combine that with biogeography, we can not only figure out who's related to who, but kind of start to figure out why this person here on this continent is maybe related to this person here on this other continent. Was there an event? Was there a land bridge that formed that allowed them to get over? Did they swim like our sloth friends? Did they fly somehow? What's going on?
So to give you a little bit more in depth and a little bit more of a visual on what this looks like, we're going to go to our map so we can kind of lay out where different animals were at and what direction and what routes they took to move to different spots.
To the map.
Alrighty, so let's look at camels and camels and llamas, or the Camelidae family. So we talked about these guys. They get their earliest start here in North America. I believe some of the earliest examples of camelids are things like Stenomylus, which is found in the Badlands of South Dakota. So we can see that we got the two ones here. So we've got camels and we've got llamas, both found at the site. So llamas, they went south. They crossed over into South America and into Central America as well. Whereas camels, they crossed back over the land bridge the other way and wound up in Eurasia. And so that's how we get the different kinds of camels that we see today.
Yeah. Next, we have the canines. So we got our wolves and our coyotes, as well as in this case modern dogs. And while they start here in North America, they eventually make it all over the world. So we see them head down to South America, as well as they go across the land bridge into Eurasia, and also Africa, and of course Australia.
And so it's one of the interesting things is, although we often view our continents as being kind of separated and by a lot of space, at one point they were touching, and at one point there was ways to get between them, and we can see that through biology by seeing these different animals that share a lot of traits and share common ancestors. We can see how these guys relate together. Let's look at another one.
Well, we got our mammoth, which starts out here in Eurasia after it comes out of Africa.
Yeah. And so he basically goes from here to here, and then he crosses the land bridge as well over into North America. And then if I'm not mistaken, proboscideans also make their way towards South America as well.
Yeah, they enter during the Gaby. They head down.
And so that's one of the really cool things about mammoths and mammoth sites is that we can find mammoth bones all over the place. So being able to get a good idea of what information we have from our site helps us put it in our piece of the puzzle in place for all of these other sites and for our understanding of the Ice Age and Pleistocene global framework as well.
Next, we got our buddy Boo Boo here, who starts out in Eurasia, and then, hey Boo Boo, let's head across this land bridge. Let's go to North America. And then, of course, the bears also head down into South America during the Gaby event, too. So, hey Boo Boo, looks like a new land bridge opened up. Let's go see what they got farther down south.
And it's interesting because when we talk about the short-faced bear, one of its closest living relatives, if not the closest living relative to it, is actually the spectacled bear that's found in South America.
I am shocked. Well, not that shocked.
We can see too, it's kind of interesting because it's one of the smaller bears we have alive today, and the short-faced bear is one of the bigger bears we have alive today, but we can tell that they're closely related, so it's kind of neat to see. Alrighty, a couple more animals that we don't have at the site but are still part of the Ice Age story and still fascinating to talk about. One being bison. You've seen in some of the Facebook Live videos we've done in the past where we talk about bison. These guys also got their start in Eurasia, and we find some of their oldest fossils, in particular bison priscus, the steppe bison. And we see these guys, they cross over here, over the land bridge, and they also wind up in North America. And although we have bison today in North America, we only have one species of bison today. And or in North America today, I should say. But in the past, we see all four species. So we see bison priscus, the steppe bison, the first one. We see bison latifrons, the ones with the really big horns. You see bison antiquus, or the ancient bison. And then, of course, everyone's favorite, the modern bison, bison. What's really neat is we can see these guys, bison, the modern one, here in North America, but we also can see the other one, the European bison, bison bonasus, in parts of Eastern Europe. And so it's kind of neat to see, again, as we were talking about, two groups that are closely related but in completely different parts of the world.
Yeah, and continuing to talk about the Gabby and what went down in Clowntown back then, well, you got your saber-toothed cats like our friend here, Smilodon, and saber-toothed cats, when that land bridge opened up, headed down into South America, and we have a new species, Smilodon populator, which was the largest Smilodon species, as well as those classic giant ground sloths that we sometimes see in the Southwest, especially in caves, as well as in the tar pits. Well, they came up north from South America and said, time to develop.
And if I'm not mistaken, not only did they crossed into North America, but they might have been swimming as well.
They might have been swimming, yeah. Swimming between islands. We have two iconic North American dinosaurs.
You mean three?
Yeah, three iconic North American dinosaurs. But what's interesting is if we look at their distribution, right? Well, the continents were a lot closer. They do have some interesting distribution going on with their families. So, sauropods, we'll stick him off to the side for the moment. Now, ceratopsians start off in Asia, and then once a land bridge in the late Cretaceous opens up, we see them, along with a couple of other families, come across that land bridge into North America. Stegosaurs we see in both North America, Asia, and Africa. But what's interesting is that the ones in Africa go extinct, and then the last of the stegosaurs go extinct in Asia. And then the ones in North America go extinct, I think, around the same time as the African ones.
And this is, although we are the Mammoth Site, we focus on the Ice Age and the Pleistocene. It is fun to talk about the dinosaurs, especially in the case of some of the ones that most people are, some of the really famous ones, because it's fun to show that not only was it happening with mammoths and the animals during the Pleistocene, but it was also happening way back during the Mesozoic as well. And it's kind of cool too, is to show that plate tectonics, the fact that continents are going to be moving around very, very slowly through time. We can't see it on our time scale, but we can see it, or we can't see it. It's not a huge movement on our time scale, but we can see it in the grand scheme. They move quite a bit.
Yeah. And so for sauropods, right, this guy, Brachiosaurus, he's what we call a macronarian, or big nose. And one specific family in Macronaria, or Titanosaurs, we actually find them on all 7 continents. Basically, if there's a landmass that we have, Madagascar, Africa, Eurasia, Australia, North America, South America, even Antarctica, we find a Titanosaur there.
It's one of the really impressive things. Like we often, when we think about biology, we think of all of these different things, and it's important also to think about, the fact that not only the animal itself, but where the animal is an extremely important part of understanding the ecosystem and the story of the world and the history of life on this planet. So in summation, it's kind of important to understand where we find animals and what kinds of animals we find in different places, because it's part of the story of the animals and a part of the story of life on Earth itself. So not only do we need to know about the animal, but where it is and where it's living is, that's an important part of the ecosystem. And not only is it important for the animals, but it's also important for the story of us as well. So as we wrap up, Colin, is there anything else you want to add?
Yeah, I think we got to talk a little bit about the story about humans, right? Their story is definitely influenced by biogeography.
Oh, absolutely. So, and of course, talking about biogeography and about the distribution of these different organisms and things like that, we would kind of be at fault if we didn't talk a little bit about humans, correct?
Of course. Yeah,
so humans also, they started in one area. The earliest human fossils, or I should say the earliest hominid fossils, so human ancestors, were found in Africa. And of course, through time, they spread out to inhabit all the different continents except Antarctica. And with that, and the last group, in order to talk about something that's a little bit more modern, a little bit more, one to think about, we've been talking about the prehistory and the paleontology aspects of biogeography, but there is a modern one, or a modern importance of it, and that's in the case of invasive species.
Yeah. So invasive species are a little bit different from natural biogeography. So if natural biogeography, like we've been talking about, is one species using land bridges or seaways to get from one area to another, invasive species are ones that are transported, sometimes by humans, sometimes by other forces, but they're transported from one landmass where they are native to a landmass where they're not native to. And these invasive species, tend to have a lot of negative impacts on the environments that they enter.
Yeah. So an example of a modern one would be things like zebra mussels, where if you've traveled with boats in different places, you want to make sure that they always talk about checking your different places, because they kind of like to hitch a ride and move to a different place and then cause problems for that over there. Another example, I guess, would probably be things like the carp, that are some of the different species of carp that are found in the Missouri and Mississippi rivers. Any other examples that you can think of for invasive species?
Yeah, so actually the Columbian exchange, which we all learned about in school, is actually an event where we do have a lot of invasive species going between the old world or the eastern hemisphere to the western hemisphere and vice versa. So a lot of those crops that we grow today are technically invasive species because they didn't grow here initially. They were brought here by people and then they started growing them here. Same with a lot of those animals we associate with farms today.
Yeah. And of course, it's one of those interesting things, like as we were talking about how different animals and different organisms will kind of adapt to their environment, and so it's one of those things where we can see how humans and how it happens on in modern scenarios as well. So it's one of those things to kind of keep in mind. So with that, I want to thank you guys for tuning in. I want to thank Colin for coming up with the idea for this video and talking it through with me and giving us a chance to explore a little bit more about paleontology and some areas of science that people might not be as familiar with when it comes to paleontology.
Of course.
And with that, we'll see you next time.